Okay, so yesterday I also kind of glossed over the atomic mass unit. I said when we're figuring formula weight, which is the weight of the compound, we sometimes, if you're asked for formula weight, you use the units AMU, which are atomic mass units. If you're asked for molar mass, you use grams per mole. When you're using formula weight, you are comparing to carbon 12. And everything in AMUs on the periodic table, the average atomic mass, is compared to carbon 12. And AMU equals 1/12 of the mass of one carbon 12 atom. And that's how they base the average atomic masses of all the naturally occurring isotopes on the periodic table. You're not going to have to do anything with this. You just have to understand what atomic mass unit is and where it came from. And understand if you're asked on a test or a quiz for formula weight, what your units should be versus what they should be for molar mass. Okay. Now, I want to do a little review of what we call base stoichiometry. And tomorrow we'll get into some of the more involved stuff tomorrow and Friday. Didn't do any of that. We've already done all that. Okay, so before we get into base stoichiometry, I have three terms, and I want to see what you can tell me about them. Molar mass, the mole, and Avogadro's number. Now, take a minute and see if you can give me a good explanation of each of those from what you know so far. If you had to define them on a quiz right now, what would you tell me about them? And then we'll go back and talk about them. When you've got what you think is a okay explanation for each one, stand up. Or if you're just to the point where you're like, I don't know, I can't remember anything about that. When you get there, stand up. All at once. Okay, walk to your lab partner and compare what you have written down. Maybe you can help each other a little bit.
I have nothing.
Kennedy! How many of you remembered Avogadro's number besides Kennedy? A couple more. Okay. Good job. All right, come on back. Okay, raise your hand if you have a sentence written down about molar mass. Jacob, what do you have?
The mass of one mole
The mass of 1 mole of a, do I have to say of a compound? I could say of a substance because it could be a compound, it could be an element, it could be a molecule. This is the mass in grams of 1 mole. Or how many atoms are in 1 mole? Atoms of a substance. Okay. Now, when we said that, or 6.02 times 10 to the 23rd atoms of a substance, kind of led us right into the mole. The mole is just called the quantity of matter. That contains. Sometimes it'll say Avogadro's number of atoms, but that is Avogadro's number. So if you think about the periodic table, and I think we talked about this in Chem 1, how the quantities that are in that periodic table box, you think about that as representing like 1 mole of whatever that element is. That's the number of grams that would be in 1 mole of it. So Avogadro's number then is, Drake, what'd you write down for Avogadro's number?
I put at 6.02 times 10 to the 23rd the amount of hydrogen atoms it takes to make 1 gram.
1 gram or? Well, yeah, 1 gram because it's hydrogen. Okay, so that's good. Let's see. How can we say that so it applies to everything? It is the number of particles in 1 mole of any substance. And that number we know is 6.02 times 10 to the 23rd atoms or particles. When we have a compound, we tend to say particles. Okay, kind of ring a bell? Now I'm going to make you think back even farther. Well, not really farther, but think a little harder. See if you can remember how many different types of problems did we cover in Chem 1. Oh, I saw, good job. I saw several of you go 3. Tell me a couple, Cole. Can you?
Atoms to grams, grams to atoms, and I couldn't tell you the third.
Okay, GA what?
N.
I gave you a little thing to remember in Chem 1 as to how many steps a problem had. Do you remember that?
GA2.
Oh, oh, GA3. These are your 3-steppers. So now let's think of what else can we go to. We can go from grams to moles, or moles back to grams.
Those are 2 steps.
Or we can get, yep, that's a 2-step. Good job, Drake.
Thank you.
What's the other thing? I can go, what's another 2-stepper?
Atoms to moles.
Atoms to moles or moles to atoms. Good. Or the reverse. Now, in Chem 1, I was very particular about your boxes and all these things. In these simple problems, I'm going to say I have to see your work. I'm not going to nitpick if you don't draw your little... But when the problems get bigger, which we'll do some tomorrow, it's a really good practice to set them up like this, or you're going to drop something.
Please note this interruption. At this time, I need all Muse members and third period choir to report to the gym and sit in the blue crew section, please. Thank you.
The whole choir must have joined. Okay, so, you know how when you're in calc, it's really easy, you're working along a problem, and you might just, like, drop a variable along the way? You know what I'm talking about? Like you had 2 t's up here, and then suddenly you only have 1 t when you're doing your... Okay, anyhow, it happens. The same thing happens sometimes with these long problems. If you don't write them out in the boxes step by step by step, you drop a step. All right, so let's look at some of this. Let's just do some example problems, just as kind of a review. And we'll see, get your periodic table and your calculators out. We'll see if you can set them up. Oh, you know what else I'm going to do as a little refresher here? I'll have you make the neutral compounds. Fun. Okay, let's say we have 412 grams, I'll start with an easy one, of sodium hydroxide. Represents how many moles? And for this first one, I do want you to use the boxes. See if you can remember. What do I put in this first box always? Yeah, whatever I'm given. 412 grams, and that's like it's over 1, even though we don't always write the 1 in there. Then I say to myself, what units do I have here? Because whatever units I have here, I need to have down here, because they have to cancel out. And then I go, where do I want to be? I find it in my problem. I want to be in moles. Can I get from grams to moles in 2 steps the way I have this set up? Yes, so I put moles here. Where do I go to find out how many grams are in 1 mole of anything? Good, the periodic table. So, I know within one of the equations, unless I'm given moles in the problem, I never use anything but 1. Now let's see, can you make sodium hydroxide neutral? What is it, Kennedy? Good, NaOH. So I just need to write those things down. It's a nice simple one. I have 1 sodium, 1 oxygen, and 1 hydrogen. I know the molar mass, check these, of nitrogen, oh no, sodium, not nitrogen. I think it's 23, is that right? Will somebody check that? Okay. Oxygen is 16, and hydrogen is 1. So, I have 40 grams per mole, which comes down here. 40 grams in 1 mole. My grams have canceled out. I'm in moles, which is where I want to be. If it's below the line, am I multiplying or dividing? Dividing. So I have 412 divided by 40, which equals what? 10 point what? 10.3 mole NaOH is what I would expect to see for your answer. Questions about anything? Ringing a bell? Okay, I'll let you see if you can set the next one up. How many atoms are present in 7.2 mole of lead to nitrate? Now, look at where you are, look at where you want to go, ask yourself 2 or 3 steps, and then make your neutral compound. Let's everybody make the neutral compound right now, and then we'll talk about it to make sure you've got it right. When you have the neutral compound, stand up. Okay, Andrew, what'd you write down?
PV, 103, 2.
2. You guys agree with him? You okay?
Yeah.
All right. He's right. Yay, Andrew. All right. Now, you want to try to set it up? Set it up. Don't do the math. Just set it up, and then we'll check it together. How many steps? 2. Okay. Raise your hand if you have it set up. Okay. Does it look like this? Oh, I'm frozen. Yes? Anybody have an answer yet? What'd you get, Kennedy? 4.3? 10 to the 24th. Adams. PB. You agree with her? I didn't punch it in yet. Yes. Okay. All right. Questions? All right, let's try this one. 968 grams of tin 4 chloride are equal to how many atoms? So here's what I want you to figure out first. Your formula and how many steps. Then when you have that, stand up. We'll check the formula before you move forward. Does that help, Cameron? You guys got to remind me to do that. Don't calculate the whole thing. When you have how many steps and when you have the formula, did you already calculate? Are you lying to me? Okay, Maria, what's the formula? SNCl4. Raise your hand if you got that. All right. Ava, how many steps?
3.
3. Good. All right. Now finish solving it. When you have an answer, I want you to stand up, and then we're going to talk just a little bit. Wake up, Drake. And if you need to see how to set it up, it's fine. Just wait. I'm gonna set it up. If you're standing up and you have an answer, when somebody else stands up, check with them.
Sure.
Thanks.
Did you two agree? Good. Cole, did you and Fletch agree? Okay, that's promising. All right, let's talk about how to set this up. Does anybody need to see how to set it up or want to see how to set it up? No, you're all perfect.
Oh, wait,
Hans, what's the molar mass of tin 4 chloride? 260 point. Okay, and that's the number of grams in what? What should be in this box? Connor? 1 mole, good. Do you guys agree with this molar mass, this 260.7? Okay, so I'm going to get rid of my grams. I'm in moles. Do I want to be in moles? No, I do not. So, Lucas, what needs to go down here? What? Does 6.02 cancel out moles? Okay, good. 1 mole. Now, Lucas, what needs to go up here? Good. 6.02 times 10 to the 23rd atoms. And when I finish that up, what do I get for an answer, Fletch? 2.24 times 10 to the what? Atoms. What else do I need to add? SnCl4. Good. Okay? You feel like it makes sense? Memory's coming back? All right. Let me stop this.